Good evening, ladies and gentlemen. Let's look at some problems from section 4.4 to help us on tomorrow's assessment. First few problems should be fairly straightforward. We'll take a look at them. State the third congruent statement that must be given to prove the triangle ABC is congruent to triangle DEF. I'm going to use the diagram and what the diagram is telling me on each problem and try to figure out that third congruent statement. This particular problem, number one, I have angle B is congruent to angle E. I have BC congruent to EF, and I want to use angle side angle. So here I have a pair of corresponding sides congruent, a pair of corresponding angles congruent, a pair of corresponding sides congruent, and I want this third angle right here. And which one is that going to be? That's going to be angle F congruent to angle C. F congruent to angle C. Similar will be number two. I want to use the angle side. And I'm given angle A is congruent to angle D. And I'm given segment AB is congruent to segment DE. And I want to use angle side. And I notice that if I use angle B and E, that would be angle side angle. So there's only one left to use, and that's angle C is congruent to angle F. In like manner, well, not in like manner, but an easy peasy problem is number three. I'm going to use side, side, side. So it's fairly clear that CB is going to be congruent to FE. On number four, I want to use the side angle side postulate. And note that I'm giving that those sides are congruent. These corresponding pair of sides are congruent, and I want to use side angle side. So I'm going to use the angle included, the angle between AB and AC, and the angle between ED and FD, and that's going to be angle A and angle D. Let's go to the next few problems. Is it possible to prove these triangles are congruent? If so, state the theorem we would use. Let's diagram this problem out. Number 5, where I have these pair of congruent angles corresponding. And then notice here, I have a linear pair of angle. That one is 90. That absolutely guarantees the other angle is 90. And I certainly know that WY is congruent to WY. So then, yes, I can indeed, let's get this thing out of there. It's bothering me. I can indeed prove these two triangles congruent because of angle, side. This is a little bit tricky to see. Number 6, can I prove those triangles congruent? Well, note the parallel line symbol. Don't forget to be looking for those parallel line symbols. And what I'm going to do is I'm going to just extend those lines. And then I'm going to go back in time a bit and look at two parallel lines cut by a transversal. What do I know about two parallel lines cut by a transversal? I know that the alternate interior angles are congruent. So I know those two angles are congruent. I'm going to clean my diagram up and say, yes, indeed, these angles are congruent because of the discussion that we just had, because of alternate interior angles. So now what do I have? I have side, pair of corresponding sides congruent. I have these angles congruent because of alternate interior angles. And I have this same segment. So yes, I can because of side, angle, side. And this is an interesting problem that we looked at today that we had some question about. We certainly did have some question about this particular problem. I don't know if we're scared of that problem. Looks like that guy is afraid, but at least maybe he's saying, hey, I don't understand. Let's see if we can't clarify it for little stick man there. Here I have a diagram that it appears that these triangles are congruent. Because if I look, I have these vertical angles are congruent. Hey, I have a pair of corresponding sides that are congruent, and I have another pair of corresponding sides congruent. So what, let's see, I have angle, side, side, or side, side, angle. We could say angle, side, side, but we know we're not allowed to say that. But either way, this is not a congruence theorem. And we want to know, why is this not a congruence theorem? And here's why. I've created a diagram here where these two segments are congruent. This segment is indeed congruent to this segment. These angles are indeed congruent to one another. And I have created these segments in a way that they indeed are congruent. So if you look at this statement, here I have a pair of corresponding angles congruent, a pair of corresponding sides congruent. Let's write it the way it's given in the diagram. I have a pair of corresponding angles congruent. I have a pair of corresponding sides congruent. And I have another pair of corresponding sides congruent. But clearly, those triangles are not congruent. And that's a good demonstration, friends, on why the angle side angle is not a congruence theorem. So let's go on to the next page and a pretty easy proof. Well, we have to be careful with this proof. Here's what we're given. We're given that I have two sets of congruent, I have a pair of congruent segments and a pair of segments that are parallel. So what does that, if you see this, it's a good idea maybe to extend, go back in time and look at those lines that are parallel cut by a transversal. What angles do I know are congruent? Well, I know this angle is congruent to this angle because of alternate interior angles. Sometimes that's hard to see. That's why I like to extend those lines, create the transversal, and then I can really see those alternate interior angles. I'm going to erase these lines and get back to the diagram in question. But from that, I do know that this angle is congruent to that angle. Angle L is congruent to angle N. So let's see if I can come up with a proof. LA is parallel to SN. That's given information. And now I know angle L is congruent to angle N because of alternate interior angles. I was given that segment LR is congruent to segment NR. That's given. And it's very easy, and I think it's very clear to see that those two angles are vertical. Therefore, those triangles are congruent. Why? Because of angle, side, angle. Good deal. So let's go to this next creature. Ooh, this one is a little bit longer, maybe a little bit tougher. So let's be very careful with this guy right here. The first thing that I'm going to do is I'm going to look at the given information. And the given information is that AB is parallel to CD. AB is parallel to CD. And AC is parallel to BD. And I want to prove these two triangles congruent. So that's going to make my claim. Here's my given statement. Easy enough. What I want to do, and I labeled the angles to make it easier to write the proof. Angle 1 is congruent to angle 2. Let's see why angle 1 is congruent to angle 2. And I'm going to do the same thing that I did before for angle 1 and 2. I'm going to extend these lines. And look at this transversal. I have parallel lines cut by a transversal, and 1 or 2 are alternate interior angles, but they're alternate interior angles from the parallel lines AC and BD, AC and BD. So if I'm going to use the alternate interior angles, and there's more than one pair of parallel lines, I have to signify which parallel lines I'm using for this statement that angle 1 is congruent to angle 2. And I have done that. AC is parallel to BD. That's why 1 is congruent to 2. I'm going to make the statement that CB is congruent to BC. This is easy for us. This is because they're the same segment. And now I'm going to make the statement that 4 is congruent to 3. Let's see here. Let's see here. Why would that be true? 4 congruent to 3. Well, I'm going to do the same thing I did before and extend these lines. Let's extend that guy in yellow. And look at this transversal. Ooh, which angles are congruent? Which angles are the alternate interior angles? That would be angle 3 and angle 4. But they are alternate interior angles by the lines A, B, and C, D. So that's the reason that I can make this statement. Is that AB is parallel to CD. AB parallel to CD. And now, what do I have? Easy enough. I have angle, side, angle, and I have triangle ABC is congruent to triangle DCB because of the angle, side, angle congruent statement. So I would review a couple of these problems for tomorrow's assessment. Tomorrow's assessment will also include problems from 4.3 and problems from 4.6, and you have a little video over those problems. Thank you, and have a good evening.